On behalf of the Field Museum, the Comer family, the Comer Foundation for Science and Education, I'm delighted to welcome Jeffrey Sachs.
Good afternoon, everybody. John, thank you very much. Stephanie, it's wonderful to see you, and a great team up of the Comer Foundation and the Field Museum. It's, for me, a big thrill to be here on behalf of visiting both organizations and visiting the Comer family, who has contributed so much to the understanding of the climate threats that are facing us right now. I also live on 85th and Central Park West, or near Central Park West in New York City, near the American Museum of Natural History, which I take to be a sister organization of the Field Museum in a lot of ways. Right, okay, fine. And so for me, I feel at home anyway, if that's all right, if you'll pardon me, but it's nice to be in this really remarkable institution. It's a thrill. Maybe I'll say just a few minutes of observations about the climate challenge right now, and then open it up for discussion, because this is just about the most complicated public policy issue that the world has ever faced in its scale, its intricate connections with all economics, with all aspects of our economy, in its scientific complexity, in its time horizon. This is not a normal problem. This is a very big problem. It's actually symptomatic of an even bigger problem, I have to say, if not meaning to be discouraging from the start, but what humanity is doing broadly to the planet, not only through greenhouse gases, but through so many other impacts as well of land use, water use, fertilizer use, shifting species, impinging on animal reservoirs, giving rise to new kinds of diseases such as the flu that we're grappling with right now, is such an unprecedented occurrence for humanity and for the Earth that we've entered a new era. It's an era that's been christened the Anthropocene, meaning that we're in the geologic age driven by human activity. It's a little frightening because we're not exactly prepared for this, and we're not very well organized for it. We're not understanding what's happening, and as the Comer Foundation has been supporting and promoting the science, we're finding more and more our vulnerability to abrupt change, to sudden discontinuities and nonlinearities in climate and in Earth systems that make a lot of Earth systems look a little bit like a time graph of Lehman Brothers shares. You go along for a while, you get a little dip for a while, you think everything's all right, and then collapse. And so the kinds of impacts that we may be putting into play, which we don't understand right now, are not necessarily going to be slow, gradual changes for which we're going to have a lot of time to adjust. The nature of Earth systems and the nature of social systems suggests that there are going to be a lot of very stark events and dislocations in a world that already has enough problems before we get there. When you look at the pure scientific aspect of this, our scientists at the Earth Institute are stressing that we're already in the era of pervasive climate change. This is not a theory about the future. It's not a hypothesis. It's something that is well underway. Attribution to human activity is, I think, certain at this point, though, as is always stressed, any particular event, a drought, a flood, a hurricane, is not necessarily to be attributed to long-term change as opposed to random fluctuations, but the totality of what's happening on the planet is certainly anthropogenic, human-driven right now. Both of our two gurus at the Earth Institute, Wally Broecker being one of them, one of the greatest Earth scientists of our time, an oceanographer who discovered the thermohaline circulation, characterized it, and many things about paleoclimate, abrupt change. And our other guru, James Hansen, who is the NASA lead scientist on climate change and heading one of the Earth Institute, we call it one of the Earth Institute units. It's actually one of NASA's units, which kindly is part of the Earth Institute, called the Goddard Institute of Space Studies. Both feel that we've arrived at levels that are already past the thresholds that we agreed in 1992 to avoid, the so-called threshold levels of dangerous anthropogenic interference in the climate system. Hansen's group in particular studies the radiative forcing of greenhouse gases. He's an atmospheric scientist. He's been modeling atmospheres starting with Venus and then turning to Earth for 40 years, and his team models the effects of greenhouse gases on the Earth, and it also explores in incredible, ingenious detail the paleoclimate record of how various kinds of forcings changed Earth's climate in the past. Hansen's view is that once we exceeded 350 parts per million of carbon dioxide, which happened some decades ago, we already had passed the threshold that the paleoclimate has shown to be a threshold of transition to a very different kind of Earth. And Hansen's feeling is that we're now in an era, because we've reached about 390 parts per million, where the breakup of the ice sheets, both of Greenland and West Antarctica, are already underway, though at a scale of hundreds of years, possibly, though it could also be as short as a century scale. So he takes the view that we've already passed thresholds, and globally we're discussing potentially stabilizing at much, much higher levels than today. That's the first message. Climate change is well underway. Its effects are pervasive. Its effects are adding to a massive range of other human activities in a nonlinear system, vulnerable to dramatic transitions, and that the thresholds quantitatively that we're hitting in carbon and in the greenhouse gases overall are very, very dangerous. Then we have, of course, a cluster of activities in our own institute, and it's part of a worldwide network, trying to understand what the human implications are of those changes that are underway. And they are profound. We see a lot of them in our own poverty reduction work in Africa, because we're working in savanna or dryland climates. And savanna climates are areas where there's a rainy season of perhaps 3 or 4 months, followed by a dry season, and arid or dryland climates may have an even shorter season and not enough rainfall to support a crop, but rather only livestock grazing on temporary grasslands. And what we're seeing all over Africa is greater instability of rainfall, more frequent droughts, and a loss of the normal. We're a break with what were assumed to be more stationary patterns of rainfall variation. So virtually all of our work areas, which are now in a dozen countries throughout tropical Africa, are feeling the effects of more unpredictable rainfall, probably less rainfall on average, certainly less in some of the places. And that's against a backdrop of rising populations and a number of other headaches. So this is, in my opinion, quite a dramatic phenomenon.